What's going on? Welcome back. In today's video, we're going to handle a case study highlighting the use of open source intelligence. Now, the scenario we're given focuses on tracking the attacker's identity. So the scenario is like that. So you have a PC here. Okay. Now the PC have been compromised. So let's highlight this as compromised. Now, this PC has also an image file. So there is SVG file. So you as the investigator, you step in, okay, you investigate and you take the image file for investigation. So what is your final destination? So you will investigate the image file to find the attackers. Who are the attackers? I don't know what happened to the pen, but let's correct this. Okay, so what you're gonna do? You will apply the OSINT for your investigation to find out information about attackers. So what you will find out? First, we will find intel on their PII. So what is PII? Personally identifiable information. Okay, so you will also be required to find out basically personal identifiable information highlights, if you don't know what is that term. So this term includes everything such as name, email, location, and other details that could be used to identify the person. Now, we will be required also here to find out their crypto transactions. We will be required also to find out or investigate the dark web activity. So, three pieces. First, we will collect the personal identifiable information, identify who is the attacker, okay? Then we will investigate the cryptocurrency transactions, see what are the transfers, what are the cryptocurrency wallets. So we will have a look at how to investigate or how to do OSINT for cryptocurrencies. Lastly, we will do or investigate, or during the process, we will also investigate the dark web activity. Not necessarily all of the activities, but we will find out, we will extract relevant details about the attacker from the dark web. All right. So let me explain first what is the scenario I have used. So basically, let me jump in here. Okay, so I'm using the scenario is from Tryhackme. The room is called Sakura Room, and we will be going over all of the tasks, okay, to highlight or find out the information. So let's go over that. So the first thing from the scenario, if you just join the room, you can download the image from here. So the image we have talked about in the diagram. So this is the image, the SVG file. The SVG file is or can be downloaded from here. So after you download that, the first question that you will find is what is the username or what username does the attacker go by? So let's go back and see how we can find this. So technically, the username of the attacker, let me switch to my virtual machine first. So if we clear ls, so I have downloaded the image to my Kali machine, and I used strings and then pipe the output to less. All right, maybe the output is overwhelming, so we don't want to be overwhelmed with all of the info. So we just pipe the output to less and we view the info. Enter. Now the first lines we review here reveals that the username is space. So as you can see on this line, it reveals the home directory, right? And most of you know that the home directory contains the usernames of the system. So we have the username is Sakura Snow Angel Eco. So you submit this and you will have the first answer. Let's go back. Now, we answered this one, reconnaissance. So then we're required to find out the email address and the attacker full name. Much like we explained here, we are now dealing with the personally identifiable information. So far, we have found, let's have a new. So first we find the username. Okay. So next thing, we will find the email address and the email address, and what was the other thing? The email and it's too much. Okay. The full name. All right, let's go back. So from here, what we can do, we can use the OSINT techniques. One of the OSINT techniques when we are giving the username is to use Google search. So let's head over to Google and see what we can find on this. So if we use Google search and take the username that we have just answered with, so first we have Reddit account, but the Reddit account doesn't reveal anything, so we're not gonna waste time on this. So here we have a LinkedIn account. So clicking on the LinkedIn account, I'm gonna show it here. So this is the LinkedIn account found by the Google search. Now, as you can see, the real name is revealed. So we can take the name and answer with this name, which is, as you can see here, is the correct answer. Now we have to find out the email address. Okay, if we go back to Google search, there is not too much details here that we can use, but the only useful piece of info here is the LinkedIn account. So reading through the description of the LinkedIn account, we see that the author here is a software engineer, and most software engineers have GitHub account. So maybe the full email address can be found from the GitHub account. So we go to GitHub. So we can replace here, as you can see from the page, GitHub/the username, and you will have access to their page. So looking through the page, we can't see any clue of an email address, right? But we can see here history of commits. Normally, the history of commits would reveal information about the author. So we have PGP, we have IO, and Ethernet, Ethereum, whatsoever, Ethereum. Okay, PGP. So we have here a public key. And most of you know that public key is not a personal identifiable information, but actually public key can be used to authenticate someone or identify a person on the internet by the public key. So if we can find a way to extract the email address or any other relevant information about that person using their public key, maybe we will be blessed with this email address. So there is a way to find that. If you take the public key and there's a decoder that's used to decode the public keys. So as you can see from the page, it's PGP decoder. So if you take the public code, the PGP public key, click on decode. So looking at the page, we can see that in the user ID packets, we have deciphered type byte, length, and the user ID, which happens to be an email address. So take that and answer with it. So right now we have uncovered the email address of the person, their full name, and the username. Now what is next to find? Unveil. Now make sure to read through the details here just to get yourself familiar with what to do next. Now this stage deals with the cryptocurrencies. So the first question is, what cryptocurrency does the attacker own a cryptocurrency wallet for? Okay, so what do we have in hand? We remember that we have the GitHub account. Looking through the commits we have IO, and we have, most probably it is Ethereum. So if you click on that, we find a script. Clicking on the script, we see here line indicating that there is a cryptocurrency activity here, or crypto activity actually. So Stratum, ETH wallet, worker ID, password, mini. So to find out, so what is the question here? The question is, what cryptocurrency does the attacker own a cryptocurrency wallet for? So it's very clear that the cryptocurrency is Ethereum. What is the attacker's cryptocurrency wallet address? Here we require to find the wallet address. And most probably finding the wallet address most of the time doesn't require you to dig deep into any cryptocurrency account. So technically, in this scenario, if you click on history, the history reveals all of the modifications that have been done in the past, including removal, modification, creation, and updating the commits. So basically, we have history of create and update. If you click on create, you see here mining script originally contains this line. Now, if you get back, no. So back to history, click on update. So on the update, we see the first line contained this, and then the author has changed it to this line. But the first line reveals the cryptocurrency or the crypto wallet address. So you copy that and you answer with it. So what mining pool did the attacker receive payments from on January 23, 2021? This requires a beginner knowledge of cryptocurrency. So when you're given here the cryptocurrency wallet address, you have to do a scan for the transactions. So this is well known in the cryptocurrency world. If you have the wallet address of any person, you can just view their transaction details and the history. So if you go to this website, Etherscan, put the address here, and this is the history that popped up. So through the history, we sort using the date time filter. If you go down, scanning through the dates, we look to January 23/1, and we see transfer from. The type of transfer is in, which means that the person has received money on their account. From, or the sender is Ethermine. That is the question. So what mining pool did the attacker receive payments from? What other cryptocurrency did the attacker exchange with using their cryptocurrency wallet? So if you go down or scroll down here, you can see there are two transactions labeled with out. So out means the attacker has transferred money to another account, or just did some kind of exchange. So we see here, it is, click on the detail of that. Nope, let's go back. So from to value. Okay, transaction hash, status, block, timestamp, from to value, transaction fee, transaction price, from Ethernet to dollar. So if you scroll down, we see we have two transactions labeled with out, meaning that the attacker, they have just transferred money to another account, or they just exchange money. We see Tether here. So they use Tether to exchange money from Ethereum to USD. So the answer is Tether. Next, don't. So of course, don't forget to read through the details. What is the attacker's current Twitter handle? So you're given a screenshot here. The screenshot reveals that the attacker has sent a message to the investigators, just taunting them that they know what they are doing, and it reveals the Twitter handle. So this is Twitter username. So take the Twitter username and find the Twitter page, which is, let me close this one. I don't need this anymore. Okay, so click X. So this is the Twitter page. Now, what is the question here? What is the attacker's current Twitter handle? Very easy to find, this one. Now, what is the URL for the location where the attacker saved their Wi-Fi SSIDs and passwords? This requires you to access the dark web. But there is an alternative way to answer the question. If you scroll down, you see there's a tweet here saying, "No more forgetting about my APs when I get new phones." Clicking on that, not too concerned about someone else finding them on the dark web. Anyone who wants them will have to do a real deep, as you can see it's uppercase, search to find where paste them. So from the screenshot and from the description here or the tweet, we can conclude that you need to access the dark web to find out the PSSID of this Wi-Fi. So you have the hash, you're given the hash. From the hash, you'll be required to convert the hash into the access points that they have used in the past. And given the fact that there is an uppercase or here assertion on the deep and on the paste D, it is very clear that we need to search with deep and paste D in the dark web. So if you open the dark web here, the website is not working for some reason. So the author has outlined an alternative way if you can't access the dark web. Obviously, this is the Tor updating. Okay, so if you can't access the dark web, you can click on the hint and you can access this URL, which contains a screenshot taken from the dark web. So if you go back, where is that? Okay, this is a screenshot. If you open it, the service name is deeppaste, and this is the URL of the dark web page that is used to find the answer. So this dark web page you enter the MD5 hash, okay, and on the MD5 hash you can see the regular access points and their passwords that the user or the author in our case has access in the past. Now here we have home Wi-Fi, name is DK1FJ, and this is the password. The question here is, what is the URL for the location where the attacker has saved their Wi-Fi SSIDs and passwords? This is the answer. You can just take it from here. This is the URL. What is the PSSID for the attacker's home Wi-Fi? Now this requires you to use Wiggle. So you're given the Wi-Fi name, and using the Wi-Fi name you can find out the location or the occurrences of points that have the name of this Wi-Fi. So if you go to wiggle.net, of course you have to create an account, and then go to view basic search. In the basic search, you have to make these fields empty, all right? Don't forget that. And in the SSID field, type the name and click on query. When you click on query, a pop-up will appear here, revealing the SSID name and the PSSID. So you take that and answer with it. And of course, along the way, here is the location of, or the home location of the attacker's home. So you have just revealed or uncovered their home address or the home location, which seems to be in Hirosaki City. You can just zoom in more to extract more details. I can just take the latitude and longitude and use Google Maps to find out more details about the location, the graphical images surrounding the home, whatsoever. Okay, unveil. So this is done. Don't. This is also done. Lastly, here you are digging through the physical location. So after we have learned that they are from Japan and their home is in Hirosaki, and we learned much more details about their personal lives, we are required here to find out their activity. Okay, so what airport they have used, what city they used to visit before they traveled back home, and lastly, we require to find out their home location. So the first question is, what airport is closest to the location the attacker shared a photo from prior to getting on their flight? So going back to the Twitter account. The Twitter account, we have a picture here saying checking out some last minute cherry blossoms before heading home. But this is the picture you need to take a look at prior to finding an answer. So as you can see, here we're required to find out an airport name or find an airport name starting from the picture. So it's very clear that we have to save the picture, save it as image, and use it in Google. So basically, if you go to Google, I'm going to do that from scratch, images, choose a file. Initially, it will give you street. Change this to cherry blossom. So as you can see, the results completely differ. Go to view similar images, and there is one result. Let me show you, where is it? The best places to photograph cherry blossoms in Washington, D.C. Also, another one is 7 places to see cherry blossoms and other blooms around Seattle. So you go to the URL and you examine the locations. The first one is saying the blossoms or cherry blossoms location first in the quad at the University of Washington. Next one is Washington Park. And we have here also Washington, Jefferson, Tacoma, also Washington. So most of the locations point that most of the cherry blossoms festivals happen in Washington, D.C. So going back and Googling airports in Washington, D.C. Since we're required to find the airport name, we have many options. So trying the options one by one, it turned out that the answer is DCA, or Ronald Reagan Washington National Airport. Now, what airport did the attacker have their last layover? So also we will use the Twitter account. We go up, this image, as you can see, we have a clue here. First class lounge, Sakura Lounge. Save that image. Downloads. Again, do a Google search. So the Google is suggesting that the place name is Jail Sakura Lounge. So Jail Sakura Lounge. So let's see what are the possible airports for this location or for this lounge. Let's examine more photos. Do we have more photos? No, only one. Let's take a look more at the question. What airport did the attacker have their last layover? So here we have Haneda Jail Sakura Lounge. Let's click on that. Tokyo International Airport, Haneda Lounge. Now, most of you will say that the answer is JAL, or JAL International Airport, Japan Airports, Airlines. So, but the question, the answer is not this. So, I know the answer is this one. I answered with this one, but I'm trying to remember how I found the answer. So basically, Ya Allah. So looking through the images in Google search. Oh, this one. So this one seems similar to the one we're looking at, or the one we have. So Japan Airlines Sakura Lounge at Haneda Airport. So Haneda Airport, I think, is the answer for this one. We just need the 3-digit codes. H code, it's HND. All right, what lake can be seen in the map shared by the attacker as they were on their final flight home? So if we go back to the Twitter account, click on the image, and we see a lake here. By the way, this is a Japan map. So let's go to Google and write Japan map. Roll it Japan. Okay. Let's take this to left and compare. See, where is this lake? Apparently here on the map, we have many lakes, but we have to find the one that is similar in looking to the let's make it satellites. So it seems this one. Let's click on that. So it's lake, I don't know Japanese, but it's lake in Awashiro. So this is the answer. What city does the attacker likely consider home? Now, to answer this question, you have to get back to your results when you answered the Wi-Fi question. So when you answered the Wi-Fi question, you found that the Wi-Fi BSSID is this one. Okay. If you click on the results, you will see that you see the location of this SSID, which happens to be in the city of Hirosaki. So that's the city, 90%, it is the city where the attacker lives in. So that was the scenario. And it is very useful scenario, actually, very cool. You start from nothing and not nothing. You start from a simple image and you walk your way through revealing the full identity of the person, their location, the personal identifiable information, their email address, accounts, their cryptocurrency activity, and much more. That's the power of open source intelligence.